All right, so we're going to get started. Feel free to walk around if you still need to walk around. As long as you're still listening and participating, I'm totally fine.
I want a bouncy ball.
You can get a bouncy ball. So one of the things we need to do is kind of establish a common language. It's really important that we all kind of use the same words. There are a lot of words, and they're big ones. We're not going to talk about all the big words in the universe because that would just take too long. In order to explore the world of autism and autism research, it's critical that we come to an agreement of the terms we will use when discussing students. There's a difference between interhemispheric connectivity and intracortical connectivity. As I was showing the picture of the brain, so the interhemispheric connectivity refers to the right side of the brain talking to the left side of the brain. Actually, that way. Right side of the brain, left side of the brain. It's still early. My brain isn't quite awake. And then intercortical connectivity. Interhemispheric connectivity is impaired in individuals on the autism spectrum. There's a delay or lack of communication between the hemispheres that is impacted as information travels via the corpus callosum or from anterior to posterior regions of the brain. Some of the early research, and I'll just go totally into the brain research and be an uber geek, talks about our students having enlarged heads. Their head circumference, pediatricians, and they go and they measure their heads and they go, oh, it's in this percentile. So what they find in some of our students is that their head circumference is enlarged. Well, what's happening, or what they suspect is happening, is that the frontal lobe of the brain is growing a lot faster than the rest of the parts of the brain. So what's happening is the frontal lobe of the brain is growing really quickly, and it's saying, okay, I'm ready to make all these connections, and it's starting to call. It's like picking up the phone and speed dialing, the occipital lobe. And the occipital lobe says, wait, I'm not there yet, just you don't rush me. And the brain is a very expensive organ to run. Let me just back that up and say that outright. It's a very expensive organ to run in terms of the body's resources. And the body is not going to continue to operate programs that are inefficient. So after a while, what happens is the frontal part of the brain says, okay, you know what, fine, I'm just going to stop calling these phone numbers because nobody's picking up and nobody's speaking my language anyway. So after a while, those connections get smaller and smaller and smaller because the brain's not going to continue to expend energy on a system that's completely inefficient. Intracortical connectivity occurs within the cerebral cortex. This is sometimes impaired because of a shortening of the dendrites that facilitate the flow of information from one area to another. So what is a dendrite? Does everybody know what a dendrite is? I'm getting some nods. Everybody does. Great! I don't have to draw my picture. Oh, I see some. Okay, well then I will draw my picture. Okay, so la 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 la. This is my little dendrite. Okay, so that's a dendrite, right? And what happens is information goes from one dendrite to another. But what happens is in our students with autism, they have little dendrites. Ow, I can't reach. And then the dendrite over here says, come on, you can do it. And it says, oh, it's too far. So this is not going to be as efficient, right? It's going to take a lot longer for information to go back and forth. And you will see this in our students over and over and over again. And, you will look at the student and you'll say, I know he's really bright. I know he's really getting this information. It just takes them a really long time to process. And you wait for it, and you wait for it, and you wait for it. And you got to have a lot of patience because this is where most educators go through the roof. And they start getting really frustrated and they start screaming at the kids. I know you understand what I'm saying, just do it. And the kid's like, ah, okay, so give them time. Sometimes our students need a lot of time to process information. And it's not that they're not getting it. It just takes a while for these connections to happen, literally for these connections to happen sometimes, right? You just gotta wait and then it'll happen and then they can kind of move on and move forward. So that is my very badly drawn picture of a dendrite. And this is why.
Quick question about that.
Yeah.
Is that why it's sometimes easier for certain students to visually see something than to hear it because it takes less processing for that particular student?
In terms of getting information from the visual cortex to other parts of their brain?
Sure.
Sure, yeah. Because those nerves go right into the brain. That definitely could be part of it, yep. I would say also that a lot of times when you write something, So I'll come over here and I'll say, hello, class. Blah, 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 blah. Now your brain has had additional seconds to look at this word and look at it and look at it and look at it. And so, you know, a lot of times what you see is that just because the image continues to stay there and it has a lot more staying power than putting words out into the air, you know, can really account for a lot of our students. I should have brought the eraser over with me. Oh well. Hello will stay there. Yes?
Can I also jump in on that?
Yes, please do.
There's also research around the auditory cortex of the brain and connectivity to the auditory cortex when it comes to autism. And whether it's as fully developed that connectivity. So when DeAnna's talking about that image staying there, the thing is words don't stay here very long. They come and go, and unfortunately new words come up right after the words that were just there. And so for brains that aren't as connected in that area, that also happens to be the area, I think we talked about mirror neurons.
Not yet.
Oh, it's coming up. You'll talk about mirror neurons. Mirror neurons actually show up in this part of the brain very strongly. So in the auditory cortex. The auditory cortex itself is different for many individuals.
Words, 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 words. Lots of words. Homo, hetero, epi, poly. Fun words. So homogeneity refers to a consistent profile of a group where there are many commonalities. Not so much the case with our students on the autism spectrum. Heterogeneity refers to a group made up of a variety of distinct individuals that have few, if any, commonalities. And then epigenetic is mechanisms that are those things that cause genes to be expressed after the DNA code is written. So for those individuals who are big proponents that it's the mercury in the vaccines, they would say that that's an epigenetic mechanism, that it was something that caused those genes to be expressed, whether it was pollution or mercury or a specific incident or a stressor or what have you. Autism is a polygenetic disorder. There are lots and lots of genes, and they're not all the same, and wouldn't it be nice if they were, because geneticists would be infinitely happy. But if you look at the gene expression of our students, it's all very different. And you see that as you see them kind of move throughout the hallways. So yeah. Pathologic sequences, abnormalities in genetic code, and Joe and I have discussed this, and abnormalities in genetic code for brain development lead to abnormal mechanisms of brain development, which in turn leads to structural and functional abnormalities of the brain, which leads to cognitive and neurological abnormalities, which gets us to behavior changes, right? So I think at some point we'll talk about organogenesis, kind of the early development of the fetus as it kind of goes from one stage to another. But what happens in fetal development is at some point the little neurons say, okay, I'm an A neuron and you're a B neuron and you're a C neuron, and we all have to go to our respective locations. And so I go to my A spot and you go to your B spot and you go to your C spot, and we're all exactly where we're supposed to be, and we're lined up and we're doing the things we need to be doing. What happens sometimes with our students on the autism spectrum is I decide I'm going to take a different route, and I'm going to go and hang out in the B spot, and you know, Nate's going to hang out in the A spot, and so those neurons are not where they're supposed to be, which makes those connections incredibly challenging. And the brain not so efficient. And one of the things you'll see with our students is they've got great brains and they're working, but they're not very efficient. Things happen very, very slowly, and they tend to be very, very distracted. So need to have efficient mechanisms. Here's the million-dollar question. Is the constellation inherent in a cohesive syndrome, or is it an artifact of diagnostic practice? What? We'll talk about that in a moment. Key clinical features in autism, things you need to keep in mind. Marked male preponderance. All you have to do is look through the hallways of this building. We definitely have more boys here than girls, and that upsets and frustrates some of our male students, but they'll get over it. Association with intellectual impairments. However, IQ ranges go from severely impaired to superior, and you know, and again, classic IQ tests are not necessarily the best ways to kind of gauge where our students are intellectually. Association with epilepsy, we talked about seizures very briefly. Association with increased head circumference, that's also something we talked about. Some genetic and related features, marked increase in familial risks. Michael and I will probably speak to this when we talk about mental health and autism, but if there isn't another relative somewhere in the family who has autism, then there's a lot of times some mental health issues that are going on. Somebody was bipolar, somebody had schizophrenia, somebody had depression, somebody, so that idea that whatever is happening is very brain driven. Increased rate of congenital anomalies, but relative non-specific, associated with increased parental age. Not to scare anybody off if they're thinking about having babies when they're much older, it's totally fine. Neurobiologic events, organogenesis.
With a younger male.
Yeah, there you go, balance it out. Organogenesis. Okay, so big word, what does it mean? So, the point of conception, and then you have an ectoderm and an endoderm and a mesoderm, right? And so those are all the little layers, and they're forming the organs, but they're also forming the neural tube. So they're forming those early pathways, and they all kind of decide where they're supposed to go. And we were talking about the neurons and their placement. Neuronal proliferation, we were talking about the dendrites being very shortened, and there's oftentimes fewer of them. If you look at the density, the sheer density of the neurons in your brain is mind-blowing. When you compare that to an individual with autism spectrum disorder, the differences are startling. Glial proliferation and migration. What's a glial? A glial is a little helper that helps your neuron. It helps give it nutrients. It helps with the myelinization, which helps in the speed and connectivity of that neuron. So it's very important. Neuronal migration, we were talking about the A, B, and C cells, neuronal organization, myelinization period, because the more something is myelinated, the faster it can go. There are certain progressive degenerative disorders that actually attack that myelin sheath and then slowly over time cause things to degenerate. Yes?
I was just wanting to go back a little bit. You said, like, what the IQ range. Like, it's a challenge for us because not just an IQ range, but you've got kids in a classroom that, like, can move very quickly and aren't challenged enough. And you've got the opposite spectrum, opposite side where they, they need all that processing time. And then when you get all these different kids in a classroom, it's can be difficult sometimes.
Yeah, it's definitely a challenge.
Really
Need to get better at differentiating curriculum and need to get better at really speaking to the individual needs of the students and figuring out and be creative about it. If it means that you take a student who is really exceptional and really bright and make them your pseudo teaching assistant, then so be it. If that's their project, and you can have them working on social skills, and you can have them working on organization, and you can have them learn and read and understand the material and then kind of help you teach, or whatever it is, get creative with it in terms of figuring out. I do not envy you that challenge because it is immense. That is for sure.
DeAnna?
Yes?
I just think one of the things that we need to get better at also is remembering that we have multiple staff often in a room. And one of our issues is often our staff moves at the same pace as the students are moving at different paces. So what we have to get better at is sometimes our staff is going to have to switch paces to match the student's pace, which means you might have one staff member who is working with students who are moving very quickly through it, and another staff member is doing exactly what DeAnna was talking about, using a differentiating curriculum to help those students move through. But we often, that's one of our issues as staff members, is we move at the same pace as the other staff members in the room, so we want kids to move with us. Sometimes we're going to need to change that up. And that's going to be very important in the therapeutic education program, guys, because you'll have kids who are moving at vastly different paces through information. You guys will have multiple different staff members who will be working with them. It's how we utilize those resources that's going to be really important.
And it's going to require a lot of organization. You're going to really have to figure out what are the standards that you're trying to teach and what is it that you're hoping to gain out of that lesson. So, you know, if you have something set up and things go horrendously south, what is it that you want to salvage out of that piece of material? Or if things are going really, really well, where do you take it in terms of taking it to the next level or kind of expanding it out? So being over-prepared is always better than being under-prepared. 28% of extreme preemies have ASD or cerebral palsy. Those 28 weekers, they've got a lot of different stuff going on. And again, that's a lot about brain development. Intact or impaired abilities in high-functioning individuals on the autism spectrum. So intact or enhanced attention. Yeah, some of our kids are either hyper-focused or really under-focused. Sensory perception, elementary motor skills. So are they ambulatory? Absolutely. You know, could they all slam dunk on people? Maybe not so much. Simple memory tasks, formal language, rule learning, visual spatial processing, and these are all provided by very basic circuitry. It's those higher level things that get a little more complicated. Complex sensory information, complex motor, complex memory, complex language, concept formation, and facial recognition. And I'm just going to speak ever so briefly on facial recognition. So there's a sequence that happens. So you've got a face, and you have shapes within that face, right? You've got circles and triangles and little lines and squigglies. So it's one thing to look at the face and be able to recognize the shapes, and then it's quite another to recognize all those shapes together as a face. And then to recognize it's not just a face, it's Donald's face, it's Jim's face, it's Nate's face. And then not only to recognize that, are you getting confused now? But to recognize, I like Donald. This is a friendly face. I want to be with this person. And so all of these things kind of, and Amanda's like, I don't know about that. But they all kind of build on one another. So it's this logical kind of progression. And you can see if one or two of those things get misplaced and tweaked, how incredibly confusing that would seem, and how much of a challenge that would present to a student in terms of learning, in terms of feeling trust and safety, and in terms of that social interaction piece. What does that all mean? What students understand is what they demonstrate, and I can't hit this home enough. It's what they demonstrate, not just what they say. This is analogous to, you know, I give you a car manual and you read the car manual and I say, tell me how to fix a carburetor, and you say, I do blah 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 blah, and I go, okay, and then I, you know, take the car manual and I send you out to the parking lot and you're just like, I don't know. It's your ability to demonstrate that working knowledge. So when a student sits down with you and you say, do you understand that if you're disrespectful, you're going to lose points? And they say, yes, I understand. If I'm disrespectful, I'm going to lose points. And then they go out and they, you know, tell the teacher to F off, or they, you know, throw a chair or whatever, and you say, you know what's going to happen. I don't know, and you didn't tell me. Make sure that that student is able to demonstrate that they do in fact understand and can perform the task that you're asking them to perform. Otherwise, you're setting yourself and the student up for an enormous amount of failure and frustration, and you're just going to end up pounding your head up against the wall. It's not going to be pretty for anybody. The gold standard of visual spatial processing is facial recognition. We just spoke of that. Simpler abilities are intact or enhanced. Information processing capacity is limited. Integrative processing and higher order cognitive abilities disproportionately are impaired. Inference and higher order brain circuitry is underdeveloped. Therefore, there is an over-reliance on lower order visual circuitry to function. When we talk about higher forms of language, when we go into idiomatic language, metaphors, similes, do we have any of our, you know, we don't, well, maybe, comm majors, there you go, my husband standing in the back, and our speech and language pathologist. That requires an enormous amount of kind of extrapolation out and into, you know, what does that word really mean? When I say the word love, everybody has an idea of what that word means to them, and they can kind of, you know, put it out there in their heads, whether it was an experience that you had or a greeting card that you read or whatever. You have a very distinct image of what that word means to you. If I say ball, you have an idea. If I say red ball, oh, now you have a very different idea. If I say red ball that bounces, now you have an even more distinct picture. And now I'm able to, with those words, red ball that bounces, able to get you to think of the same thing that I'm thinking of. Now you have a very specific image in your head. It's not just of any ball, it's of a red ball that bounces. And so that's how we use language to convey very specifically sometimes that we all kind of want people to be thinking the same things that we're thinking about. So, yes, sir. Go for it. No, you can.
This is one thing that Temple Grandin talks about, actually. And so if you've had a chance to read Temple Grandin's work, she talks about the fact that for her red ball that bounces, there are several different red balls that bounce. She has to image all of those different red balls that bounce. Because for her, there's no universal category of red ball that bounces. See, for us, we immediately flash to something. For her, a bunch of different things flash up because there are a bunch of different red balls that bounce. This is why sometimes when we talk about inference in higher order language, we think, well, this kid should have gotten this because I gave him a really simple direction. I said, go over there and pick that up. Okay? Which seems like a pretty simple direction, except for you have to figure out where there is and what that is. And those aren't very explicit directions. They require a lot of inferencing. They require a lot of figuring out. If my brain also then needs a lot of this extra kind of processing, we have a number of kids like this. In fact, some of our kids who we see as very high functioning are kids that when I've sat down with them and done some talking through different kinds of things like this, they'll tell me exactly what they think it is, and it's dramatically different than what's being said to them. Their thought, their perception is dramatically different. So language itself is a very abstract thing. So this isn't just idiomatic. This is language itself is an abstract process. So I just wanted to.
And it requires an enormous amount of perspective taking. When you say go over there and pick that up, I need to be able, in my head, to place myself in the position that you're in and view the world literally the way that you're viewing it. And that's an incredibly challenging task for a lot of our students. It can be challenging for neurotypical individuals to put yourself in other people's shoes, but really be able to kind of view the world the way that that person views it. I had a young man who had a visual impairment. He was a kindergartner, teeny tiny little guy, and he drew a picture. The assignment was draw a picture of your classroom. So he drew a whole bunch of knees. And because for him, that's what he saw. He saw everybody's knees. And the teacher looked at the picture and she goes, okay. Everybody else had drawn like little desks and whole bodies. But for him, he was drawing the world literally the way that he saw it, which was everybody's knees, because that's about where he was at. So just kind of think about what our students see. Where does it all go wrong? Wouldn't that be nice to know? The genes that determine where and how brain cells or neurons are connected and talk to each other are affected. How do we promote connectivity? Use symbols to help students with concepts, teeter-totters for turn-taking, that kind of thing. Promote the development of categorizing things, and repetition of information over and over and over again in different settings, with different people, with different tones. Repetition is a wonderful, wonderful way, because what you're doing is you're building in an experiential component to it. For example, I got married a couple of years ago, and before we got married, we went to a dance choreographer, and we said, teach us a wedding dance, and we're doing it in a little studio, da-da-da-da-da. And then we get to the day of the wedding, and we're in the dance hall, and the nerves are pounding, because it's a different place, right? It's a different floor, it's different walls, it's different music, you've got a lot of people around. So it would be nice if we had practiced it a million times in that specific dance hall. But of course, that's not the way the world works, because you don't always necessarily get access to your. But constantly, having the student repeat and do the activity where they're ultimately going to be expected to do it. Common challenges: literal thinking, associative thinking. There's a lot of interesting board games out there that kind of deal with associative thinking, but I like to give the example. I was driving home from work, and it started to rain, and my brother was in the back. My brother has autism, and he was in the back seat, and my husband was to the right of me, and it started to rain. And I said, "Oh, I hope it's going to let up," because a coworker of ours was getting married. I said, "I hope it doesn't rain for her wedding day." And my husband, who is a music nerd, says, "Wouldn't that be ironic?" You know, of course, going with the Alanis Morissette. And then my brother from the back goes on this long tangent about a video game sequence that he had watched, where there was rain, and then there was bombs, and somebody had died, and it was just like, whoa, okay. So it was a very associative thinking interaction that was happening in that car. And I just kind of turned to him, and I said, "Associative thinking," and he goes, "Yeah." So definitely happens a lot with our students. Processing of verbal information is slower and less efficient. Interpreting sensory information is also a challenge. Most children conform to the standards and images adults set for them because they follow the usual developmental sequence. There's a wonderful excerpt, and I don't know if you can find it on YouTube or on the web anymore at all. But what they did was they brought a parent and a child into a room, and they had one of the children had Down syndrome. And they brought in a little robot, and the robot came into the room, and the parent was supposed to overreact and be completely startled and terrified. And so the parent starts screaming, "Ah, ah, ah!" And the little kid looks at the robot and goes over and starts kicking the robot and smashing the robot. And then in comes a parent and a student with autism. And again, in comes the robot and the parent, "Oh, oh, oh!" And the kid looks at the robot and looks at the parent and looks at the robot and doesn't react at all. There was no idea that they were supposed to be taking their cues, that what just walked into the room, the parent was perceiving as something very, very dangerous and something very threatening. And kids do this all the time, little toddlers, they're running and they fall. And what's the first thing they do? They look up, right? Should I be scared? Should this hurt? What's going to happen? And sometimes parents will be like, "Oh, it's so good," and they just lose it. And other times parents, "You're fine, come on, let's go." And then the kid's fine. And they walk up and they're like, "Oh, okay, well, mom says I'm fine, then I'm fine." So that ability to take your cues from the adults around you is really, really important. And that's a glitch that our students definitely struggle with. What happened? What the heck? Whoa. Oh, here we are. They want to please those that are important to them. This is a lot of relationship-driven stuff. This is a lot of stuff that our students struggle with. So if you think by saying, "It would make me really happy if you sat nicely," that they're going to sit nicely, you've got another thing coming. Because sometimes our students will just look at you and be like, "Oh, really? Well, then I'll definitely stand." Or, "I don't care. What's going to make me happy? What drives me? Why should I be concerned about what makes you happy?" Because in their head, it becomes really challenging to then extrapolate over time what the significance of that encounter is. We have built up through experience that quid pro quo. Well, if I get you a cup of coffee this morning, maybe in a couple of days you'll get me a cup of coffee. Or maybe if I need to borrow $1, you'll be more likely to do that. Or we have that idea that we're kind of building up relationship points. For them, that's not so much the case. It becomes really a struggle for them to figure those things out. And though our students will struggle with that relationship part over and over and over again, I would remind you to just kind of help them see that over time that, okay, you know what, we can still be friends and I still want to work with you and this is okay, but when you're in the work situation or when you go to college, if you tell your professor, F you, that's going to be a problem. You're probably going to fail. Yes?
I'm thinking about this concept of relationship points in terms of video game. And a lot of role-playing games, you will literally build up points for doing those kinds of things. Has there been any research on if that's helpful for kids with autism?
I don't know, but you're right. There are a lot of Mass Effect and Assassin's Creed, and a lot of those are contingent upon you doing other missions for other characters in the game and building up points. But I don't know. That would be interesting. They cooperate more with adults who reason with them. Good luck reasoning with some of our students sometimes. please remember that they're teenagers, after all, and teenagers aren't always the most reasonable, rational individuals in the universe. They got a lot of hormones going on. It's a very confusing time of their life. It's very challenging for everybody involved. So yeah, model their behavior from the people they love, admire, and see rewarded. So that's what most children learn to understand others through empathy, perception of social cues, role-taking, and communication. Develop autonomy through successful experiences, and develop embarrassment, shame, and guilt when they fail to be like others. Students with a variety of disabilities may have difficulty conforming to the standards and images adults set for them, and may have difficulty cooperating with and learning from others. However, when the child does not conform to the standards set for them by adults, we tend to see them as being oppositional, non-compliant, defiant, and resistant. I would strongly recommend that you not necessarily label our students as such. It is a struggle. As we were speaking to earlier in the presentation, their brains are really wired very differently. Their perception of the world and the reality in which they live in is very, very different. It's not necessarily that they're being willful or intentionally trying to be malicious. Sometimes they just don't get it. You know, a student comes up and says, "You're old, you're fat." These are, in their mind, these are very concrete things. You know, you're old and you're fat. And, you know, they don't understand that that can be hurtful necessarily. They're just being honest. You know, and for them, that's a good thing. It's important for them to be honest, right? We always teach them, don't lie, tell the truth, be honest. So that's what they do. Something to ponder. Students need people to believe in them. Absolutely, and who better than us, so that they can believe in themselves. And when kids have confidence, they can do anything. So it's really, really important to be their advocates, to help them learn self-advocacy. I couldn't stress that enough. So yeah, any questions? We're out of slides, I think. Are we out of slides? I think we're out of slides. Should I click? Yeah?